Okay, looks like that everything is work now. Hey guys, what's up? My name is Igor. I'm DevOps from Innovecs, and today I would like to talk with you a bit about Terraform, best practices, tips, and tricks from my perspective. So let me introduce myself in a few words. I'm working as DevOps about 5 years. My main stack, this is AWS, Python, CI/CD, which includes GitHub Actions, Jenkins, and automation tools, Chief, Ansible, and so on. But I believe that you would like to listen about Terraform, not about me, and it's okay. So let's begin. Okay, where is my mouse? Yeah, here we are. So what I would like to talk today about? So I would like to start from bad practice, and we will move step by step to the best practice. Okay, so I would like to emphasize that best practice it's not to put all Terraform resources into the one file. Because first of all, it won't be comfortable for you to read that code. For example, if you will have an opportunity to read that code, if that code will try to read another developer, it will be hard for him or her to understand what's going on there. The second point I write down it's hard code values. A bit later, I'll show you how it looks like inside of code, but for now, we will describe everything bad which can happen in Terraform stuff. Again, about another developers, it's use unclear variables. So if variables, for example, mean cat, don't call that variable dog, because you will know that that variable exactly cat, but if someone else will try to read your code, he or she will understand that it's not cat, it's dog. So please use clear variable. Don't duplicate code. If code looks like similar, please try to not duplicate it. Again, I'll show you how it looks like inside of code a bit later. As soon as Terraform it's language which can describe infrastructure with the code, so please don't do manual changes if your infrastructure covered with Terraform. As soon as later, when you try to understand what's going on, it's starting harder and harder. You need to ping a lot of people who works with Terraform in your team and find out what's going on and who changed it inside of AWS, GCP, or Azure, doesn't matter. And don't deploy your Terraform from your feature branch. As soon after you deploy it, we don't have that code in main branch, and if someone from your team will try to deploy that code, he will see that something will be changed as soon as Terraform don't know that you have already applied the change. And Terraform won't know it because the change is not in main branch, for example, but in your feature branch. Okay, so this is code, and that code is written exactly in one file. So here we specified everything. AWS instance, for example, variables, security groups, and so on. Here I write bold font, and I would like to emphasize that don't do it in that way. And we will understand why we shouldn't do it in that way. So let's move on. And here we also have AWS DB instance, security group for the DB instance, and everything inside one file. It's really not readable. And about duplication code, as I told you previously, don't duplicate code if you can exclude it. For example, we have two similar Cloudflare records where we have different only zone ID and value. So I'll show you a bit later how can we, instead of duplication code, use another function and write it in the proper way. Okay, we discussed with you bad practice, and now let's go with best practice. So as we discussed with you, we shouldn't write everything in one file. So please separate Terraform files based on the logic. Under the logic, I mean logical Terraform stuff like variables, some resources, providers, and so on. So you will see a whole structure, and you will see where exactly you should do the appropriate change to change your infrastructure. Okay, instead of hard code, which we've seen with you previously on previous slides, please use variables. And I will describe why we should do it. And variables name should be clear. We already discussed it with you. Duplication code we already discussed. Use modules. This is interesting thing, and we will talk about modules a bit later with you. Don't change manual Terraform current resources. It's also, we've already discussed it with you. And deploy Terraform only from the main branch. Okay, let's check a code which we should have. For example, here we have variables.tf file and data.tf file. In variables file, we specify all variables which we are using inside of Terraform project, and we will understand that if we need to change some value, we will go directly to variables and we will change it directly in variables, not in data or I don't know, or in providers files, directly in variables. And we don't need in that case read all 1,000 codes to find appropriate place where should we do it. Okay, here also separated data file, sorry. And this is main file. Inside of main file, we are working with all variables which we defined here, and all data resource which we have previously defined, and we using everything here. So as we discussed with you previously, instead of hard code, we are using variables here. Why it's good to use variables? For example, if you would like to change variable, which we would like to change project name, for example, we need to do it only in one place in variables. For example, previously it was backend responsibility, now it's front end. We will change that value in one place, and it will be changed through the code everywhere. And you don't need to find each value with Ctrl F, for example, or something like that, and replace it in everywhere through the code. Especially if you have about 1,000 lines of code or more. Okay. Okay. And about duplication code. Sorry, guys. About duplication code. So as we saw previously, we had two Cloudflare records. And we duplicate the two Cloudflare records, and we had two different values. So instead of that, I propose to use for each function where you specify host name, zone ID, and load balancer. And with for each, you can choose appropriate value for each Cloudflare record. So it's in the loop, we are choosing each key value 0, for example. For first case, we get that one. For second case, we get that one. And in that way, we create two similar records, but with less amount of code. As soon as previously developers were paid by quantity lines of code, so it's not our case, and now we should write clear code instead of duplication. Okay, let's move on. On this slide, I would like to describe you how Terraform works. So for Terraform, it doesn't matter. Will you separate file to 7, 5, or doesn't matter how many files you will have. For Terraform, Terraform will render everything into the one file and deploy it. So in that case, it's logically separated and it's readable code. In the second way, the Terraform, from the Terraform perspective, is the same. But for you, here will be uncomfortable to read each line of code if everything specified directly in one file. So please separate your files based on the logic. Okay, we already mentioned with you modules. Why do we need and when should we use it? Okay, let's imagine that we need to create Bastion. Bastion is an instance from which you can connect to the private network and so on. It's not our topic for today, but let's continue. We need to create Bastion. Bastion will include next resources. So AWS instance themselves, Elastic IP address, which allows us to connect to the appropriate instance, Elastic IP association, security group, and security group rules. So I calculated all that lines, and I will show you why I do it. So it's about 40 lines, if I'm not mistaken. Yeah, okay, amazing. We can create Bastion. We can create Bastion from all that resource in 3 different projects. So each project will have, for example, 40 lines. And if we count how many lines will we have in all projects, it will be about 120. But let's imagine that you need to add one additional security group rule. For example, your office has been changed, or you open new office and you need to add to your VPN network one additional IP address. So in that case, instead of 9 lines, you will have 19 lines in security group rules. But let's imagine that you should do it in 3 different places: in project 1, project 2, and project 3. It's not so difficult. Really, it's not so difficult if you have, for example, 3 projects. But let's imagine that you have 10, 12, doesn't matter. And here starts mess. When you need to change that IP address in every project, it's starting to be really difficult. So instead of that, we can use module. So we specify everything inside of module, and we still have that 40 lines. But when we will call that module, we will have only 10 lines of code, and we will just transfer variables for that module, and module will create for us appropriate resources. So let me check the next slide. Yeah, exactly. So inside of some Terraform project, you will write only 10 lines of code with variables. You transfer that variables to module, and module will create for you all that resource which you described. And instead of 30 lines of code, instead of 120 lines of code, you need to manage only 30. And if you need to change one security group rule, you will do it directly inside of module, not inside of the project. And it's really cool and comfortable. Yeah, you can decide to separate appropriate amount of resources to module, and use that module. So module, it's a logical collection of resources which you will use several times, for example, or more than twice in different resources. Okay, cool. And yeah, one more interesting thing is from my side. This is flexibility of modules. When we create modules, we can define which resources should be created and which resources shouldn't be created based on if condition. For example, this is a real example from my project, and when we create an ECS service, we can have 2 ways for creation DNS records. This is Cloudflare record and Route 53. So if we specify for modules that we would like to create a Cloudflare record, we transferring into the module provider Cloudflare. And here we can see that if variable provider is equal Cloudflare, we will use count as 1 and will create a Cloudflare record. If we would like to specify, for example, for module road 53, we transfer in road 53. In first case, we check in var provider equal Cloudflare. No, it's equal road 53, for example. In that case, we will see that count will equal 0 and that resource won't be created. In the next case, we will see that we will check var variable is equal road 53. Yes, and we are creating road 53. So based on that, you can tune your modules and make them as flexible as possible. Okay, one more interesting topic as for me, it's providers. Why do we need providers and issue related to that? Okay, so when we are working with providers, we are doing next stuff. For example, we are cloning Terraform code. After that, we getting the Terraform code from GitHub, and after that, we doing Terraform init for opportunity to work with Terraform. In that case, we downloading all required providers from GitHub, and we collecting everything in .terraform folder, which created automatically by Terraform. After that, we doing Terraform plan, and everything perfect. It works as expected, and we are happy. Let's imagine, let's switch to the next situation, which I really had in my experience, when we had almost the same situation. We are doing git clone, everything the same. We are pulling Terraform code, we doing Terraform init, we getting provider, we doing Terraform plan, and you can see that it's failed. You're starting to think what's going on. Yesterday it works just fine, really. You didn't change anything. You go to the GitHub, you check in commits, and nothing changed. Amazing. You're trying to understand what's going on. You ask your colleague, for example, could you please do Terraform plan? Yes, your colleague do Terraform plan, and everything just fine. It's work as expected. But from your side, it doesn't work. Magic? No, it's not magic, and this is a provider issue. And it's work on your colleague side only because your colleague doesn't do Terraform init, and provider still the same version as it was yesterday for me, for example. And to exclude that situation, you should pay attention to that one. So in the root of project, you specify providers which you are using inside of Terraform. And if you specify, for example, version should be more than 4.21.0, and from yesterday, AWS provider has been changed from 4.21.0 to 4.22.0, and in that case, something can be broken. And first of all, if you have such situation, you have a broken project, please go to the GitHub and check was provider updated during that period of time or no. Because I spent about 1 hour to realize that it's really root cause inside of provider, and it's really interesting situation. Okay. What would you like to see here? Yeah, one more tip about providers. So I advise you to specify version of providers directly in the root of your project. And if you need to use that provider inside of application, you will specify it just Cloudflare, for example, and you'll specify just it in that way. In that case, if you will declare a provider version in root directory, if you need to upgrade provider's version, you need to change it just in one place, in the root providers file, and it will be inherited by all another application, and you you will be happy. Okay, it's about providers. Yeah. Okay, yeah. Now I would like to talk with you about importing existing resources from AWS into Terraform. So what can we see here? Okay, let's imagine that we've already had infrastructure in AWS. I'm showing you AWS because I'm working closely with AWS. And you have RDS database, for example, which you need to import into Terraform. So how can you do it? You can do it with Terraform import, and you need to specify for Terraform resource ID, which should be imported. So under the import resources, you need to clarify everything with Terraform documentation, official documentation, because each resource has each special importing ID, and you can check it in Terraform documentation. So this is algorithm. How can you import existing resources to Terraform? So first of all, you need to create code for resource which you would like to import. For example, in our case, this is AWS RDS. You create a code. After that, you need to do Terraform plan. After Terraform plan, you will see in output that one resource will be created, and it's good. It's good, everything is okay, and we on the right direction. After that, you need to do direct import. As soon as Terraform doesn't know anything about your RDS, which was created manually, you need to do import. After you import database with appropriate ID, you need again to do Terraform plan. And that Terraform plan on the last stage should show you that now infrastructure is up to date. In that case, it means that you successfully imported RDS into the Terraform, and now Terraform understands that this is Terraform responsibility to manage that RDS which was created manually. If you will change something in that RDS manually, Terraform will notify you about it during the next Terraform plan. Okay. For example, here I would like to show you how can we move resources if a resource has already been covered with Terraform. For example, instance is living in one application and you decided to move it to another application, for example, to application 2. So what command should you use in that? In that case, you need to use Terraform state MV, where you specify a source ID and destination ID. And in that case, Terraform will manage everything inside of its Terraform file. We can do it also with different approach. We can remove it from here, for example, and we can import it here, for example. But it's not logical as for me, and it's easier way to use Terraform state move resources. Yeah, let's move on and let's discuss how can we do it from one project to another. For example, we have instance in one project and we would like to move it to another project. In that way, we should use Terraform import resource and Terraform RM state resource. In that case, we don't have an opportunity to use Terraform move command. As soon as here we will use two different Terraform state files. One for project 1 and another for project 2. In that case, we are doing next things. We are covering instance from project 1 in project 2. We're covering it with code, and we doing Terraform import. And we check what Terraform plan will show for us. If everything is up to date, everything is good, and we are good, and we done Terraform import successfully. After that, we need to remove that instance from state file of project 1. as soon as one resource should be managed by one Terraform state file. If you will manage one resource with two Terraform state files, it will be mess. Because first time you will overwrite text, for example, project one. After that, you will try to do plan here, and plan here will show you that I would like to overwrite text to project two because its instance is living inside of project two, and it will be too hard if you will use one resource in several Terraform state files. Okay, let's move to the next command. Yeah, here I would like to show you how can we use Terraform plan refresh only or Terraform apply refresh only. Okay, let me underline that Terraform official documentation doesn't advise you to do it, so be careful about that one. And probably I also don't recommend to do it, but you should know that we still have such command. And what does that command actually do? Okay, for example, here we are. For example, we are doing manual change in the AWS. And Terraform doesn't know about that manual change. To reflect that manual change into the Terraform state file, we can do Terraform plan or Terraform apply refresh only. In that case, if you did manual change, it will be reflected into the Terraform. For example, if you remove that instance manually, Terraform will told you during the next plan that one new resource will be created. But if you will use Terraform apply refresh only, in that case, Terraform will remove it from state file and forget about that instance. Okay, yeah, looks like that I would like to talk with you about data resource here. Let me check. Yeah. So, okay, here. For example, we would like to create a security group rule for instance from project one into the inside of project two to have an opportunity to connect from project one to project two. What should we do in that case? We need to get IP address of instance and to create that security group rule. Okay, how can we do it? One moment, yeah. Let me check. Yeah, we can do it with data resource. So what data resource actually do? Data resource will get that IP address for you and will apply it directly into project two. So to create security group rule in project two, we need IP address from project one. To get that IP address by Terraform, we should use data AWS instance resource. And in that case, we will get that IP address and create a security group rule. But pay attention that when we use data resource, we are doing API call to AWS. And everything good if you need just one IP address, for example, to create security group rule. But let's imagine that you need not only IP address, but from that project you need VPC ID, VPC CIDR, I don't know, database IP, and so on. So what should we do in that case? In that case, we should use data Terraform remote state file. In that case, what Terraform will do? Terraform will call AWS and get Terraform state file from project one, where you can describe everything which you need with output resources. So, for example, you need IP address of database, you need IP address of Bastion instance, so on and so on. So here you need to describe everything with output. After that, you can use Terraform state file, and inside of that Terraform state file, you will have all that outputs which you need. And in that case, instead of one IP address, you will have an opportunity to use VPC ID, subnet ID, IP, and so on. And in that case, you will do also only one API call, but in different with previous situation, which we had here. So with one API call, we get only one attribute, its IP address. Here, we will get all attributes which we have inside of project one. And also we will do it with one API call. So it's better to use remote state file when you need a lot of information. In that case, your Terraform won't be so uploaded as in difference with the first case. Okay. Yeah, I would like also emphasize Terraform tags. Why do we need it? I guess that all of you feel that pain when you're trying to find a responsible person and ask why that resource, for example, instance, spends so a lot of money. And in that case, you first of all, you need to check Terraform tags. And if you don't have anything there, you starting that Sherlock stuff. You're starting to find appropriate person to ask why we have such a big bill. And here I like when everything is covered with text. And to make your life easier, I propose to use default text. Default text. What the default text allow us to do? If you specify default text inside of root of project, you will cover all resources in that project with text. So you specify it in one place, and that resources, that default text will be inherited by all resources from project. And in that case, you don't need to remember, have you covered appropriate resource with text or no? And in that case, when you will have such situation about reviewing cost, you will definitely know in few seconds who is responsible for that instance and who should be asked about why do we have such a big cost. Okay, cool. It's a tip. This is tip about default text. I guess that it can be useful for you. And let's discuss a bit Terraform upgrade. So not so long time ago, Terraform version has been released with version 1.0.1, and how should the upgrade be done? Let's check it a bit. So I just paste here a print screen from official Terraform documentation, and I would like to add several more words here. For example, if you are using now version 0.11 or version 0.12 and you would like to upgrade it to the latest version, please read Terraform documentation about that one. As soon as you probably don't have an opportunity, just download the latest version of Terraform and do Terraform plan and Terraform apply. Probably it won't work for you. For example, if you are using Terraform version 0.11, at first you need to upgrade it at least to version 13. And after that, you need step by step to follow documentation to upgrade it to the latest version. And only after all the steps, you will have an opportunity to use the latest version of Terraform. As for me, it's quite important information, and you can use it. Okay, and some useful Terraform command which also can make easier your life. I like Terraform FMT. I forget to add here recursively. So that command prepare your Terraform code in the appropriate view. It's clean code and readable code, and you can work about several hours on the code, and you don't need to format it. Terraform will do everything for you. Terraform console, I'm using that command when I need to debug something locally. I don't need to do Terraform apply to check will it work for me or no. Instead of that, I can run my tests inside of Terraform console. Terraform console, this is equal like you can run Python 3 on your local machine and do anything which you need inside of that terminal. Terraform validate. Terraform validate also can check for you if your code is clear and every variable specified, and Terraform doesn't require from your side anything more. If that code can be applied, for example. Terraform validate also, this is a part of Terraform plan. So when you are running Terraform plan, at first Terraform do Terraform validate. Only after that, Terraform do Terraform plan, and only after that you can do Terraform apply. Okay, Terraform state list. Terraform state list can show you all resources which you have inside of your project. It also can help you during the debug process when you lost some resource and so on. The same about Terraform providers. When you run Terraform providers command, you will see all providers in the tree view, where you can see exact application and which provider is used by exact application, and it's really readable and useful. And I believe useful tips which I would like to share with you. It's keep infra up to date as soon as Terraform. This is main purpose for that one. And when you get up at the middle of the night and your infrastructure is down, you have downtime, your customer losing money, and you need to understand what's going on. At first, you can do Terraform plan, and Terraform will show you what's going on and what resource has been changed. And after Terraform plan, you can just apply and everything will be fixed. But if you do manual changes, for example, at the midnight, you will see that manual changes. And if it's not only one change, for example, but it's about 10 changes, you need to understand what the changes was about. And it's not really cool. Yeah, I wrote down also manual changes acceptable in urgency. If you have downtime, you don't need to cover your infra right now with Terraform. So it takes time to cover your infra with Terraform. After that, you need to do plan, apply, and so on. Instead of that, you can do everything manually. Your infra will be up, and only after that you can cover without any pressure your Terraform code, and everything will be up to date. Yeah, about import and moving resource. Please notify your team that you are doing that importing, moving process as soon as you are working with Terraform state file. If you and your teammate, for example, will do it simultaneously, Terraform, you can browse the Terraform state file, and it will be not so cool to debug what should you do next, and so on. So please notify it first that you are doing that stuff for now, and notify that you finished with importing, and your team can work with the Terraform state file. Okay, keep versioning of Terraform state file. Yeah, exactly. In case, for example, if you break your Terraform state file with your colleagues during simultaneous apply of code, you can easily get previous version of state file, apply it, and everything will be great. But if you don't have that file, you need to fix broken file, and it will take more time than just to replace it with previous version and deploy. That's about it. Okay, and also my advice is update providers with each update continuously. For example, we've already talked with you about providers, and today, for example, today it works, tomorrow it won't work as soon as provider will update it. But imagine situation that this is only one upgrade. But if you pin, for example, version 1, but for today actual version is 5, you need to understand what was the wrong with previous version. Yeah, it can be skipped also as soon as, for example, from version 1 to version 2, a provider had a bug, but from version 1 to version 3 and 5, that bug has been fixed. But anyway, I believe that one by one, upgrade your providers. It will be easier to debug if you have such bugs. Okay, yeah, guys, probably that's all on my part. So let's move to the question part. I don't see any questions right now. Yeah, good question. Is it good to save output of plan? It's really great question, and yes, answer yes. Let me describe why. When you are doing a Terraform plan and save it to out plan, for example, you have next benefits. For example, you done Terraform plan, everything looks fine. You see that one resource will be updated. For example, let's call database. Let's call database, and you are changing instance type from dbt2 medium to dbt2 large. You can see it in Terraform that only instance type will be changed. Let's imagine situation, I haven't seen such situation, but let's imagine that after you do in Terraform apply, you see next situation, your database has been removed. For example, you're trying to understand what's going on. And first of all, you will go to the Terraform plan and you will see that database will be upgraded from one instance type to another instance type. And you really can see it in Terraform. You can get the Terraform plan and go to AWS support, for example, and show that plan for support and ask what's going on, why it was performed deletion instead of upgrading instance type. And yeah, they also can take a look, can check all logs, and this can be, for example, a problem of provider and something like that. This is imagined situation, but this was in my head. Best practice to store state file. I don't think so that this is best practice to store a state file, and let's imagine that you will deploy Terraform about 10 times per day, and each time you need to store the Terraform state file. Oh, sorry, best practice to store yeah, sorry, I read that question in the wrong direction. Yes, best place to store state file. From my point of view, best place to store state file, this is S3 bucket, and enable versioning. When you enable versioning, you can save yourself from break Terraform state file, and if it's broken, you can revert previous version and use it. I hope I answered your question. Any other question, guys? Oh, Erekle connected. When multiple engineers want to start deploying infrastructure using the same state file, what would the best practice for this case? Good question, and that question has already covered with Terraform, Terraform mechanism and log mechanism. So when, for example, I'm doing Terraform plan, I've already pushed enter on the Terraform plan stage, and you would like to do the same, for example, at the same time. You also push enter on Terraform plan, and you will see a message that Ihor has already logged Terraform state file, and he's working with that one. Please wait till it's finished, and only after I will finish my deployment, you will have an opportunity to work with Terraform state file. This is log mechanism of Terraform. Yeah, exactly. Terraform. That's why Terraform is powerful thing. Any other questions? Okay, guys, if you don't have any other question, I don't want to spend your time, because I appreciate your time and that you connected to listen my thoughts about Terraform. So I think we can finish with that one. Thanks everyone for your attention. Stay healthy. Goodbye, guys.
Hello, my name is Erekle Magradze. I'm co-founder of DevOps Georgia, and also I'm working as a lead DevOps engineer at Quantori, Georgia. I'm also a professor at Ilia State University and enthusiast of new and challenging technologies. I'm trying to learn them and share the knowledge. Today I will be talking about event-driven autoscaling for Kubernetes. But before that, I will shortly describe my experience in IT field. So I have more than 15 years of experience in IT. I started working as a system administrator, though I had like mathematical education in the beginning. I've been doing also coding when I was doing my PhD, and gained quite some academic experience within LHC experiments at CERN. After that, I gained quite some experience in industry. Especially, I was working with IoT company in Germany, and I learned a lot during this period. Especially, I learned about at that time it was quite new. I learned about DevOps core technologies, and also I learned about big data systems a lot on industry scale. I learned about Kafka and its usage. I learned about Spark, etc., etc. So many different interesting technologies that were quite new at that time and in a quite immature phase. So, and as I said, my passion is basically to learn interesting and fascinating technologies, understand them, and share experience, and also share the ideas and concepts how I understand them. Maybe I got it wrong, and I like to discuss about these topics usually. So why I decided to speak today about autoscaling with Kubernetes. So as I mentioned, I've been working in the industry for quite some time, and I've been dealing mostly with time series data. Actually, I've been dealing with time series data also during my academic research, and but I discovered that when we are talking about time series data from IoT devices, that could be the main data source generating the time series data, right? Then we can face huge amounts of data coming in a very short period of time. And for that, you need something powerful that can handle this load. Um, this challenge was common not only for us, as for a small company, small IoT company, but it was common for many big companies like Uber, LinkedIn, etc. They are processing huge amounts of data in a very short period of time and very efficiently. So this is the basis and basics to provide the online systems for the customers. So without data streaming nowadays, it's impossible to serve online or near online system to big number of customers. So that's why, of course, we dealt with Kafka because this is one of the best tools for handling and open source tools for handling huge amounts of messages and huge amounts of data load. It's a big monster. It consists of many components. It consists of many parts. We are not going to dive deep today in Kafka because it's separate topic for another presentation. However, it has main components, key components that are like producers. We can consider as a piece of software that generates, that communicates with Kafka brokers and generates data and pushes this data to the Kafka topics. Topics we can consider if we talk from the database perspective. So topic can be considered as a database table and or database itself, and topic can be partitioned. So topic can be split. So Kafka, first of all, I should mention that Kafka is a distributed system. It's a multi-node system. It's not a single node or monolithic system. So that's why it's very well suited for the microservice deployment and microservice architecture. It is very much flexible in terms of horizontal scaling. So you can add more and more nodes and scale the power of Kafka as much as you want. And in particular, if you would like to have lots of quick processing of the data that's been arrived in the Kafka topics, right? So you need to have lots of consumers. Consumer we can consider as a piece of software that reads data from the topics, right? Basically, Kafka provides capability to split this data into chunks and distribute them over the nodes, over the Kafka nodes, and then the consumers are reading these chunks from different nodes very quickly. So if there are multiple consumers and we have replication factor more than one, then basically we can speed up our reading process tremendously. So we can gain huge performance with Kafka because of its architecture, because of its granular structure. So it has very well suited microservice suited architecture. So it's very natural to think about deployment of Kafka on the Kubernetes. And of course, when I was dealing and when I was understanding concepts of Kafka together with my colleagues, we're doing main core Kafka development. I'm not a Kafka developer. Maybe I'm a guy who knows how to set up and prepare the infrastructure for Kafka, test the auto-scaling features, etc. But I can do some very simple stuff with Python. And Kafka especially provides, Confluence provides really nice Confluent Kafka Python package that is very much powerful, and I loved it because it's very easy to use. And with Python package, you are basically able to write producer, consumer, experiment with it, and do lots of things in a very easy way. And also, by the way, with Confluent Kafka Python package, you can do also the streaming experiments as well. So on parallel of understanding and learning more and more about Kafka, I started getting deep dive in Kubernetes. Actually, at that time, it was also quite a new technology. There were not that many good tutorials. Documentation was also quite general. It was not that straightforward and easy to understand how to deploy what. I'm talking about open source project, not about the commercial, for example, OpenShift or something like that. So if you wanted to deploy Kubernetes on premises, which was the case at the beginning, right? It wasn't that straightforward. So it took also some time to understand all this. Then cloud-based Kubernetes deployments became available and life became easier and simpler, right? And we got time to concentrate on more interesting topics. So basically, when we are talking about Kafka, it's a very well microservice-suited piece of software. And when we are talking about Kubernetes, Kubernetes is the best platform from my perspective, to deploy the microservices in a containerized way, right? And naturally, I wanted to put this together and also to see how the scaling or auto-scaling or horizontal pod auto-scaling of Kubernetes will work, right? So horizontal pod autoscaling in Kubernetes is a very well-known concept, but it's limited to only CPU and memory metrics, and you need to do lots of other things to take into account all the other metrics. And this was when you are dealing with Kafka, you don't have that much time to investigate all the possible options in Kubernetes. And vice versa. So everyone was trying to find out the easy solution for that. Basically, the horizontal pod autoscaler was working fine for these simple cases, but in case of Kafka, you have many different other parameters, like Kafka lag, for example, right? That basically tells you how many how many messages were not consumed, right? So where is the head of the consumer and where is the head of the where basically is the last messages so where is the head of the producer, let's say, to say it in a simple terms, right? So if there is some certain kind of mismatch, and you know that like there are like 5 or 10 or 20 messages that were not consumed, then we have a Kafka lag, right? And this Kafka lag could be critical, and it could be a good indicator that consumers are not enough. So consumers are not enough to consume all the messages that are coming from outside, right? And that's why you would like to monitor rather Kafka lag than CPU or memory consumption. CPU and memory consumption could be fine, but that is a bad indicator to scale up the number of consumers. We were investigating, and of course, we found out that there is a Kubernetes event-driven auto-scaling, which is also not that which has been kicked off not that long time ago. It's an open source project. It's cloud native foundation incubation project, and it's been as far as I remember, it's been developed in collaboration with Microsoft Azure. So, and this basically KEDA allows to do many different things. Especially, it helps you if you are a Kubernetes administrator or DevOps engineer who would like to make infrastructure flexible and scalable. It helps to collect different metrics from services. It has so-called scalers, different scalers, which are able to communicate with Prometheus, which are able to communicate with Istio, which are able to communicate, for example, with traffic, etc., etc. So they're able to fetch metrics, different metrics from different sources. So it's quite powerful tool, and here is one of the example that basically it checks the ingress controller's data, which are fetched from and it checks the ingress controller's performance. This data is fetched from Prometheus. Prometheus is a monitoring tool for Kubernetes, and then it does auto-scaling according to the metrics, right, provided by Prometheus. Or it can also directly fetch metrics from the ingress controller. This picture I took from the link below, so it's an interesting case also. Basically, why this is important, why we're talking about it in general. This is important because if we want to deploy services or lambdas, so serverless functions in cloud, we're charged for each function and for each serverless deployment, right? So basically, if we would like to reduce the charges or make our infrastructure adaptable to the load, which means that when we will have lots of messages in Kafka, for example, the number should increase, and when there will be kind of not that big, huge, not that big load in terms of messages, the number of consumers should automatically scale down, right? So this kind of flexibility is something that will save lots of money, right? And also human resources, because you can do it also manually, but then you have to sit down and or you need a dedicated person who will follow up all this process and do this manual interaction with the cloud infrastructure, right? So basically, Keda solved this problem, and I wanted to show a demo today where basically I will use Minikube. Why I decided to use Minikube? First of all, Minikube is something that allows you to run everything on your instance, and I love to run and to do the experiments and POCs on my instance. And there is a Streamsy Kafka available here over this URL. With Streamsy Kafka, you can download, you can deploy easily entire Kafka cluster in the Minikube. This is very helpful and handy if you would like to run different experiments with streaming, with number of consumers, with different configurations of, let's say, consumer groups partitioning, etc., etc. And also, I have written by myself several scripts that are available here on my GitHub account. And these are basically two things. So consumer and producer. Producer simply reads some dummy data from data CSV file. I will show this as well. Okay. Oops. I will switch to this here. So producer simply does the following. I have a data CSV file here available. So there are just timestamps and some values, some random values available. Then I have a producer.py script. As I said, I have some experience in Python, so I'm using it as much as possible. And basically what I'm doing, I'm trying to connect with Kafka cluster, and I'm providing the name of the topic, and I'm fetching. So I'm in case of producer, I am reading the file, reading the data from the file, communicating with Kafka broker, and publishing messages with certain intensity, right? So I can also regulate the intensity. This is one thing. Also, I have a Docker file that puts all the producer and the data CSV file into the Docker image. And why I need the Docker image? Because I would like to deploy this particular microservice kind of in the Kubernetes. So in particular, in my case, on Minikube. Also, I have the producer deployment file. So basically, it's a simple deployment without any exposure of the services, etc. So I have just one replica, and that's it. Basically, nothing really complicated. So I've put together all these components, and I have basically I should be able to deploy this on Minikube. This is the producer part. But of course, beforehand, I have to deploy the Kafka cluster. And on the consumer side, I have again the consumer script that again communicates with the Kafka cluster. It communicates with some group because when we are talking about consumer number of consumers, they should be grouped somehow. This is important because of the offset of the messages. If we are doing synchronous and kind of sorted streaming, and we would like to receive messages one after each other, which is quite complicated and complex case, then we really need to take care of these offsets, share this information between the consumers, etc., etc. But this is so complex and so rare, I would say, that in majority of cases we are using asynchronous read. We are reading whatever is available. If there is a timestamp, then we can simply write this data into the database and sort the data according to the timestamp. So, and then the problem will be solved, right? And if we are using, for example, database like Cassandra or MongoDB, then we can easily get rid of duplicates, right? Okay, so I have some default topic configuration, and then I'm again passing the name of the topic as an argument. So nothing really complex here again, and I'm putting together all this into the Docker file, which is here. And as you can see, basically I'm providing the name of the topic here, right in the Docker image. I have hard-coded it. Of course, you can provide it as an environment parameter to the Docker image when you will run it. It's up to you, but I just simplified the case. And of course, what I'm doing next is deployment. Sorry, it's not a deployment. Deployment is here, consumer deployment. Consumer deployment is available here. So I'm again doing nothing special, just pay attention to the following. So I'm allocating very small CPU and small memory for the consumers. And the replication, so replica of this deployment will be 1, not more. So this is also important to know because, and remember, because thing is that we will see how the number of replicas will increase with help of KEDA. And here is the KEDA consumer configuration, and this is the most important. So how it works with, maybe I will even split this window to have a good comparison. Here, like this, consumer.py, not consumer.py, but maybe consumer deployment, right? So here we have the following. So here we have the scaled object, so-called. Scaled object will be deployed in the Kubernetes. Of course, beforehand we need to install the KEDA using Helm. This is the best way to install the KEDA in our Kubernetes cluster. So it needs dedicated namespace. We will do all this. And the most important part here is that we have here scale target, right? Scale target reference. And the scale target reference name and the name of the deployment that we have here, they coincide, right? So they are the same. That's the whole catch here. So KEDA scaled object deployment is simply monitoring the deployment on the Kubernetes. And if it identifies that there is like one message behind the latest read, so it identifies that there is at least one message that is not read yet, then it starts scaling, right? And this is good case. Usually we write here 10 or 100 if we have powerful Kubernetes cluster and powerful nodes, etc. But since we are doing all this now on the Minikube, 1 is reasonable number. So if we will have at least one node behind one message, sorry, which is not processed, then definitely we need to scale up and we will be able to see the scaled up services, scaled up consumer. So basically, it then we are writing here the minimum replica. It's 0, but usually it's better to write it like 1 maybe, because 0 replicas means that there will not be running any consumers. However, it's possible in case of consumer. In case of other services, like if you are providing some web service or something like that, it's not a good idea to put their minimum replica count 0. It's better to have at least 1 replica if you have constantly serving service running. And max replica count is 10. It's logical, right? So it's the maximum number of replicas that we'll have. And cooldown period is like 5 seconds. So during 5 seconds, it's checking if the number of messages is decreasing in the Kafka, and then it starts reducing the number of consumers. And pulling interval 1, so it constantly checks in every second what is changing in terms of Kafka. And since we have, since we would like to scale up our consumers based on Kafka, we are using Kafka scaler, so-called Kafka scaler, right? So it's here, it's described triggers. We're writing here Kafka, and if we go here, KEDA.sh, right? We can also quickly find out that there are different types of scalers. You can find out that there are lots of scalers for ActiveMQ, Kafka, CloudWatch, DynamoDB, Kinesis Stream, many scalers are available there. So you can choose and use it. And it's the documentation is quite thorough, so you can understand how to use it. Here are the examples. You can go here, and you can find out how to use it. Quite straightforward and easy. I love it. That's why I'm saying so many details about KEDA. And here we are specifying the name of the Bootstrap server and the port that will be running inside the Minikube cluster. We are specifying here the name of the namespace that we are going to use, because with our deployment, that as we mentioned, we are using the Streamz IO deployment. So let me, hopefully it will open quickly. So yeah, it's really Kafka on Kubernetes in a few minutes. That's really it. It's quite straightforward. You can find out, let me check if I will be able to find out the quick guide here. Yeah, so you can read also lots of details about Kafka and understand how it works. So if we'll get back to this, to our topic, basically that's it. So we have specified the Kafka broker, it's looking into it. We are using some consumer group that is created, and then we are also specifying the topic name, which is important, just that the scaler is monitoring the topic and the messages in it and the consumption of these messages. And offset policies latest, it always checks the latest changes in the queue. So I will not go in the topic, I will not go in the details on this. So basically we overviewed the consumer and the producer. Now we should try to run the demo, and hopefully everything will go smoothly. Okay, so right now I have the following situation. I'm running everything on Ubuntu instance, so I will simply run or like this. I will specify that I would like to run Minikube with KVM driver. Then I will specify the memory for the Minikube, and then the Minikube will be running, will be up and running, hopefully very soon. So it's creating the disk, all the images and templates to run this KVM machine is there. If we check here, so it's here, you can see that it appeared. Okay, so I think we'll have putting out control plane, so it's running already the Kubernetes services. So it's basically a virtual machine that is running inside the KVM virtual, so KVM virtualization. And inside this virtual machine, it's deploying basically containers, Docker containers to run the entire Kubernetes, small Kubernetes cluster, right? Okay, so kubectl get all, let's see. Yeah, get, so now we have this. What we would like to do now is to create the kubectl create namespace KEDA for KEDA, and we also would like to create namespace for Kafka. Okay, so basically we are get ns. We are ready to go with Kafka deployment first. So let's see, Kafka create. Let me check. kubectl create. Okay. We can quickly refer to our Streamz.io and try to deploy it. Just 1 second. Yeah, there we go. So this is basically a good case for Kubernetes. So we already created the Kafka namespace. Now we can simply apply this huge template for deploying the Kafka cluster, which is prepared by SteamC for us. So let's run it. And yes, that's created. That's great. Now we can provision. So these are basically the cluster role bindings, etc. that we just created. Now we will deploy the Kafka cluster itself. But before deployment, let me check if everything is up and running. So in your creating, let's wait a bit. It will be up and running very soon. And by the way, we can also launch the Minikube dashboard. This will help us to visualize all the changes and progress ongoing in our local Kubernetes cluster. So it will open the link immediately. So let's check what is going here. Oops. Yeah, we had to anyway deploy this KEDA as well. So we have installed the KEDA core. Let's see what is happening. It's also in the container creation phase. So basically, we ask to create the Kafka cluster, and we also deploy the KEDA controller in the Kubernetes cluster. Let's see what is going on in Kafka. Okay, let's wait a bit. And in the meantime, yeah, we should get it. Okay. Let's deploy the Kafka cluster from StreamC. Let's try to run it. And yeah, so it complains that there is no Kafka namespace. So I need to create the Kafka namespace before. There we go. And now we will deploy the Kafka cluster inside the Kafka namespace. And let's see what is going on. Okay, weird. Okay, obstacle create namespace Kafka. Let's create it. And let's try to deploy it now. Okay, get all -n Kafka. No resources found. That's strange. Let's check in the dashboard. There we go. Let's check in the dashboard what is going on here. Strange. So we're waiting to put up all the cluster roles, cluster role binding, and all necessary base containers for Streamsy Kafka. Let's wait. So it's container creating. It's in the container creating phase. So it should be up and running very soon. It's pulling the container image and trying to deploy it. So we're waiting to put up all the cluster roles, cluster role binding, and all necessary base containers for Streamsy Kafka. Let's wait. So it's container creating. It's in the container creating phase. So it should be up and running very soon. It's pulling the container image and trying to deploy it. So with this command, we're able to deploy the necessary rules and role binding on our Minikube cluster. Now let's try to deploy the Kafka cluster itself. I will switch off again. Okay, so we can see that now our Kafka cluster has almost been created. So we just need to have this one in up mode. Let's see. Let's wait a bit. So it should be up in a very few moments. That's it. So now it's up and running. Now what we would like to do, now we would like to so basically prepare for KEDA. So we can go here, KEDA SH, go to the deploying KEDA. That's straightforward. Okay. And we can add the Helm repository for KEDA here, which is already there in my case. And we can on Helm update if we need it, but it's also not needed in my case as well. But it's fetching the latest images if they are there. Okay. And now basically we will create the namespace KEDA. And again, run the Helm installation with KEDA. Okay, get all minus Kafka. That's good. That's up and running. You see that there are like 3 replicas running there. And let's see what is going in KEDA. So it's also almost there. But in the meantime, we can try to run the producer. We can try to run the producer and deploy basically the Kafka image. So deploy the producer, push lots of Kafka images to the Kafka cluster. So let's try to run this producer deployment, apply, create. It should be the default namespace. And yeah, it's container creating phase. Let's see, should work. Now we have running producer, there it is. And also we have up and running KEDA deployment. So let's check what is going on in the producer. So producer should be generating lots of data messages. Yes, it's generating lots of data messages, as you can see, and these messages are all pushed into the Kafka cluster. So let's see now. I also launched so dashboard. We should be able to see the dashboard right now. We see that on the dashboard we have like one producer, and also we can check on in the Kafka namespace that like deployed Kafka here, and we have also here KEDA deployments. Okay, so now the key thing here, what I'm going to do, I would like to show you is so that should appear here. Here we go. So here, the KEDA consumer first of all. So we need to do now two things. First of all, we need to deploy the this scaling group information here, scale object, and let's simply deploy it. KEDA consumer apply -f KEDA consumer, right? And this has been created. This is good. And now let's also create the consumer deployment, what is more important. And now we should be able to see here that the consumer deployment has been created. Our consumer is also up and running. Right now, let's check what is going on now with this consumer. Logs, consumer. We don't have yet anything. Let's wait a bit. Hopefully it will work. So probably there is some communication problem with Kafka. Let's check. Let's wait a bit. Let me. Everything seems to be correct here. And Docker file here as well. Okay. Yeah. The main problem here is, of course, that we have created the Kafka cluster. We have created the producer consumer. Producer will create. So we can also check the list of the topics that are available there. Let's check. This is the tool for checking basically inside what we have, what kind of topics we have there. And it seems that we don't have the topic we are trying to consume. Okay, that's not a problem. We will simply stop the producer. That's not an issue. And we will create the topic with, this is important point now. So we will create the topic with the name KEDA demo topic, just for convenience. And oh, by the way, maybe it's also a good idea to delete the consumer deployment. Let's check if they're both gone. So they are in the terminating state on the dashboard, which is good. So let's create the KDA demo topic with 3 partitions and with replication factor 1, since we have one small cluster, so there is no need to have multiple brokers, etc. So we just have one replica and 3 partitions, which allows to run at least 3 consumers for this topic. So let's create this. Okay, we can also actually delete topic. Since this topic has been created automatically when we started the producer. Okay. Okay. Mm-hmm. Mm-hmm. So let's create the topic. Yes. So we just created the KDA demo topic with 3 partitions, 1 replication factor. So 3 partitions means that we'll have at least 3 consumers running there, which is something that we definitely need. We would like to see the scaling of the deployments. Now let's apply -f producer deployment. So that should now generate the messages. Right, producer is up and running. This is cool. And let's now try to run get all. Let's try to run now the consumer. And let's check our dashboard, what is going on here. So consumer is will be created in a second, and hopefully it will start scaling up. And by the way, we can check all the details like horizontal pod, autoscaler, pods, scaling objects like this. And we see here that the horizontal pod autoscaler has been automatically created, and the scaled object component that we also created now is active. And here are all the parameters that we had in the configuration file. So let's see what will happen now. See, here we have, so right now you can see here that 3 consumers got started. See, so we just launched 1 consumer, and because of we had like 3 partitions in this one topic, and when we started consumer, just 1 replica, the KIDA looked into the Kafka messages, found out that basically there is some lag, and it launched 2 other instances. And you can see here that they are now managed by KIDA. So 2 other instances are managed. All of them are managed right now by KIDA. So once we started one, it immediately triggered to launch 2 more. Here we see them. So basically, this is the power of KIDA. It's not that easy and straightforward to demonstrate all this on a very small instance with Minikube. But if you check here, at least the consumer and the producer is here. And later, I will also add some more details to this repository documentation to be able to simulate the same with the Minikube. So definitely you will need the KIDA deployment short quick start, and also you can also follow this streamz.io, and here is the quick start guide. And with the quick start guide, you can easily deploy everything in the Minikube. So basically, I've managed to show all what I wanted to show. In particular, that KEDA did its job, even on the Minikube. It scaled up the consumers because of the lag, and that worked fine actually. So we can see what is going on now with this here. So see, just created, yeah, we immediately got 3 consumers, and we are having still 3 consumers. Let's check what is going on in one of them. So they should be okay. They are not printing the logs, but at least one of them should be able to print the messages. But if the messages are over, of course they are not going to print anything. Okay, it seems that messages are very well consumed immediately, so but they are still produced. Okay, so basically our consumers and autoscaling example worked well, and you can see you saw that basically KEDA did its job, what we wanted to show you. Now it's draining down, it's trying to reduce the number, so to decrease the load on the Kubernetes cluster, and that's it. So basically all the details will be available in the GitHub as well, besides these recordings.